All right, good afternoon. We'll get started. My name is Riley Edwards, and on behalf of all of us here in the Rail Transportation and Engineering Center, welcome to our William W. Hay Railroad Engineering Seminar today. I'll start out with a few safety-related items. Please, if we have a fire alarm go off, we'll exit out the doors to either side of the room. We'll go down to the ground floor, the first floor, and we'll go across the street to the north and gather by the Civil and Environmental Engineering building. Please use the buddy system, so note who's beside of you. Make sure you get out safely. In the event that we have severe weather, we will exit these doors, go down the stairwells to our west over here, and we'll go down into the basement to a safe place until we figure out that it's safe outside to return. A couple of quick announcements before we get started with our Hay seminar. As you can see up on the screen, and those of you on the online audience, in a couple of months, from the 9th to the 10th of June of this year, we're going to be hosting the International Cross-Tie and Fastening System Symposium. We've hosted this event approximately every other year since 2012. It's been a fantastic opportunity to get together with rail professionals to talk about the track superstructure, all the different components and how they're used in the track system. We're very grateful for a variety of sponsors that help us promote this event, and grateful especially for our partnership with the Railway Tie Association. You can see some of the topics over there that are covered in that list. And I want to identify Marcus Dersch in the back of the room. Marcus has been instrumental in developing the technical program for this, and we're excited to have hopefully many of you back to campus this summer. So with that being said, now I'd like to introduce our speaker today and talk to you a little bit more about the William Hay Railroad Engineering Seminar Series here at the University of Illinois. First of all, we want to thank the AAR, CN, Hansen Professional Services, and the FRA-funded National University Rail Center of Excellence for their ongoing support of us here in RailTech. Those of us in the room appreciate it. The funded graduate students appreciate it, and I know you in the online audience appreciate it as well. Today, we have about 150 people that have gathered online from 4 different countries, and this includes people from passenger and freight railroads, the engineering consulting firms, suppliers, and many others. So we're grateful that so many of you chose to join today. If you wish to receive PDHs for today's presentation, please follow either the guidance in your email, or feel free to the email that announced this seminar, or feel free to send an email directly to hayseminar@illinois.edu. So now I'd like to announce today's presentation and the speaker. We have guests here today from Metra, much to our excitement. If you're not familiar with Metra, especially those that may be tuning in from a long way away, Metra oversees all commuter rail operations in northeastern Illinois, serving 242 stations on 11 lines. Metra is the 4th busiest commuter rail system in the U.S. by ridership, and they have a unique system in terms of the ownership and operation of each one of their lines. Today's presentation will introduce Metra and describe the planning and execution of many of their capital projects, especially those that are designed to enhance the customer experience. These infrastructure improvements will reduce train delays and increase Metra's on-time performance. Example projects include signal upgrades for greater fluidity and track and bridge upgrades to increase capacity. So now I'd like to introduce our speaker, Mr. Scott Schiemann. Scott was appointed the Chief Engineering Officer at Metra in March of 2024. He oversees system-wide track, signal, bridge, electrical, telecommunications, station, and facility engineering at Metra. Mr. Schiemann earned his BS in Civil Engineering from the University of Illinois, Chicago, and a master's in Infrastructure Management from the Illinois Institute of Technology. Mr. Schiemann began his career in the railroad industry after 6 years of service in the U.S. Air Force National Guard. He previously served as Chief Engineer of the Belt Railway of Chicago, where he led infrastructure programs across bridges and buildings, signals and communications, and track. He's a registered PE in Illinois and was recognized as a Progressive Railroading Rising Star in 2019 for his role in improving safety, infrastructure performance, and project delivery. On a personal note, I want to say on behalf of all of us here at RailTech that we're grateful to have you, Scott, here. And Kevin, nice to meet you today and have you here in town. We've had a long-standing connection with Metra. We've been able to take students to see many of your capital projects. Production groups working. We've installed infrastructure or instrumentation on your infrastructure, and we're excited about today's conversations and to see where we're going in the future. So I'd like for all of you to join me in welcoming Mr. Schiemann, who will present today's Hay seminar titled Enhancing the Customer Experience Through Capital Investment at Metra.
All right, thank you, Riley. Can you hear me? All right, good morning, everyone. Thank you for the introduction. Really humbling, Riley. I don't realize stuff I've done until sometimes when it's repeated, but really appreciate the introduction. Today I'm going to go over, Metra's, some of our capital plan, things we work on. I'm going to talk about things kind of behind the scenes that you don't see every day. For those of you that know Metra, most people know the station you get on, and then let's say you get downtown or you get to a suburban location. You don't realize that that's maybe 10% of our infrastructure. There's the whole 90% behind the curtain that most people don't see day to day and why we do things. So today I'm going to go over kind of a little bit of a peek behind the curtain. So I don't know if you want to have this as an open dialogue or at the end, Riley, people ask questions, but I'm kind of an open book. So however, whatever you guys want to ask. So, is there a pointer on this? Okay. So yeah, I was just going to go over a little bit of my history. Riley went over it. I was going to go over what about Metra, where we're located, what we do, kind of how we grade ourselves, which is what we in the industry call on-time performance, and then some capital projects we're doing to increase the customer experience through on-time performance, through the quality of the ride we provide, the neighborhoods we ride through. So just going to touch on a little bit of everything Metra is doing. So as Riley said, I'm the chief engineer at Metra. I went to your sister agency, UIC in Chicago. There was always a little rivalry when I went there that Champaign was better than UIC. I don't know if they still think that way, but I started working full time, and then I got my master's grad night from IIT, as Riley stated. And so I've worked for freight railroads and then now for Metra. And those of you that are studying it, there are two different animals. So freight railroads, heavy tonnage, commuter is faster, shorter queues and all that. But it's two different animals, and both are very important. But you got to look at things in different lights. And so Metra is a mixed use system. You have freight and passenger, so you got to think of both when you do your projects. So just a little bit about our engineering department. We're at Metra 750 employees. The majority of that is union employees, over 600 union employees and over 100 in management. And the union employees range from, trackmen and women, signalmen and women, electricians, what we call B&B, which is bridges and buildings, so carpenters, plumbers, all the trades. And then the the management employees, we have, frontline supervisors, we have designers, we have budgets, project managers, all types of jobs. So we're kind of like a self-sustaining city almost. So here's Metra's system. For those of you who don't know, we operate on 11 lines throughout Chicago. So what is to the left here is all our lines. So we run 671 trains a day on 11 lines. Our goal is to run all those trains on time at a goal of 95% or better. And what Metra says on time is a train that is supposed to arrive at a time within 5 minutes. Anything over 5 minutes is considered late or not on time. So there's 671 trains a day. That means approximately 30 trains or less can be late. So our goal is obviously we want 100%. And so what we're going to go over today is certain things that affect that on-time performance and how we can improve it. So, but of this system map, the 11 lines, we maintain 5 of those with our workforce. So the Milwaukee District North, the Milwaukee District West, the Southwest Service, the Rock Island, and the Metra Electric are owned and maintained by Metra. The other 6 lines are maintained by our freight partners. So the UP maintains their main lines, the BN maintains their main line, and the CN maintains their main line. So we have to coordinate with all these groups to make sure we run these 671 trains a day. So what affects on-time performance? This is a scenario that happens. We have a drunk driver. drive on our tracks, right? That's what we would call uncontrollable. We can't control if John Q. Public doesn't do what they're supposed to do. We also have things like a bridge strike. If any of you've been on a Metra train, if there's a bridge strike, you have to stop train movement until it gets inspected. Or there's a trespasser on the right of way and the police are trying to obtain this person, we have to stop train traffic. So all these events are affecting our on-time performance. So that goes into that total bucket of the 671 trains a day. So these are what we would call uncontrollable. But what can we work on ourselves? What's controllable within engineering, within Metra, is a slow order on the track. If you're running trains, if there's a slow order, if there's a defect on the track, that's slowing down trains. We can fix that. So that's a controllable delay. Switch failures are controllable. Coordinating traffic and like working with our freight trains, we call all that controllable because if you coordinate and you're proactive, you can prevent the delays. So for those of you that don't know, this area right here is called Forest Hill. This is part of a CREATE project where you can see these 6 lines are all interfacing, right? And so you have delays here because only one can go at a time or 2 can go at a time. So what the CREATE program is saying, let's engineer out these controllable delays, right? So this is one scenario where let's get rid of the controllable delay, we'll build an overpass. But obviously everything takes time and money. And this is approximately a $450 million project, grade separated, the CSX over the belt and Metra here. So now Metra's on time, we benefit from this project. Our on-time performance will go up because we can run unimpeded and CSX can go over us. So these are how big capital investments from the federal government increase our on-time performance. So how do we enhance the customer experience? As I stated in the beginning, it's not just one thing. So you want reliable on-time service, right? So that's what we call OTP, on-time performance. How is your ride, the rideability? We want a smooth ride. We don't want you to spill your cup of coffee. So that's the in-track infrastructure we want to maintain. Here's a new platform. You want a new station and platform that people enjoy going to and getting on a train. And then our lines go through hundreds of neighborhoods through the city of Chicago and through all the suburbs. Are we being good neighborhoods or is it an eyesore to look at our tracks? So we're going to use capital to improve all these pieces on and off the train. So just showing, this is like our 5-year capital plan, but what I just wanted to touch on is, I don't know if this works. The lion's share of our capital is our rolling stock. About 44% is, locomotives, cars, all that. That's the lion's share. What's customer facing stations and parkings is only 10%. So, the lion's share is the rolling stock and everything in between that most people don't see is what is getting you to your destination. So what Metra's trying to experiment with on the train is things like this. We've experimented with what we call a cafe car. Is it a feasible option to serve coffee on trains? Because those of you that aren't from Chicago, a lot of our stations had coffee shops in them, and the profitability, a lot of them have closed now. So can we make a new option and serve coffee on our trains? So this is something we're experimenting with. Another thing Metra works on is holiday trains. So every holiday season, we decorate trains, but we also host some special holiday trains in December, and it sells out instantly. So this is, something we've experimented with that proved totally viable and people enjoy it. So we're going to continue to do it. Our CEO is a Navy veteran. As Riley stated, I'm an Air Force veteran and Kevin's an Air Force veteran. So there's a big push within Metra to acknowledge veterans. So this is running around our system, this locomotive. This was designed in-house by our mechanical forces and painted in-house to honor veterans. Metra is also now has veterans preference during hiring. So this is an initiative that we just took on in the past year. And kind of switching gears now off the train is, are we being good neighbors in the neighborhoods that we run through? So this is on the Rock Island line at 95th Street. We were detraining passengers in the middle of a crossing. So obviously not the safest scenario for our customers. So we diverted capital funds and built a new platform where one didn't exist to make sure that people were getting on and off the train in a safe location. So the before and after is, you know, we added this platform that didn't exist. This is another thing about just enhancing your ride is, this is on the Southwest service, is the picture on the left is an abandoned station that was there, probably abandoned over 50 years ago, between our tracks, that had caught on fire 25 years ago. And every time people leave Union Station, they're going to go past this burned building and see it. And that's the eyesore they see when they ride Metra. So we demoed that. And then the bottom right is the demo platform is gone. So we're trying to, you know, when you're looking out the window of Metra, what do you see? We want you to see a nice clean right of way. We don't want you to see burned up old platforms and canopies. So kind of another thing too is we're working with all the neighborhoods we run through, is so all our tracks in the city of Chicago are elevated. This is a closed sidewalk. I don't know if you can see, because a retaining wall here is blowing out. That was built in the late, 1800s probably. So we're working with the neighborhoods we run through to provide, service so that, everyday people can walk past our tracks. So we demoed out that old retaining wall. You can see we cut all the trees, and then we're putting nice new decorative jersey barriers. These are just capital investments we're doing into our infrastructure and the neighborhoods so that we have a win-win for everyone. Same thing here is, here's a neighborhood where this is an alley to people's houses that back up to our tracks. The wall blew out and they couldn't even, get into their garage. We need to be good neighbors here. So we did the same scenario here where we demoed out the old wall here. And then these gentlemen built a base with CA6 and then a new retaining wall. And for those of you that don't know, this here, this fill is beach sand from the dunes in Indiana. So a lot of the railroads, when they elevated them, they built basically a box. The retaining walls and then the viaducts at all the road crossings filled that box with sand because sand compresses instantaneous. There was no need to compact it. So a lot of the infrastructure in Chicago, the elevated tracks, if you dig into them, you will see this perfectly clean beach sand, because that's how they elevated the tracks. So they built the trestle and then dumped the beach sand from up above and buried the trestle. So this is kind of like a final product of, this newer retaining wall, and then we'll final grade, but just showing how we're trying to be good stewards in the neighborhoods we run through. So switching gears now into more traditional engineering projects, talking about how do we enhance the system? What is delaying trains? So at this juncture where that arrow is pointed, that's a Milwaukee District North. CP traffic runs north-south, and Metra traffic needs to go left to Fox Lake there. So the issue at that juncture where the arrow is we have a single track going over a creek to then get to Fox Lake. So only one train in and one train out can go on that whole Fox Lake sub, which is approximately 18 miles. So if there's a train that wants to, if there's a train that needs to come west and there's already an eastbound train, there's nowhere for it to stop. So it has to stop miles back and wait for this. So that currently costs delaying these trains like 5 to 8 minutes. So what our solution is, build a double track over the creek here. Now you can have a passing siding so that one train can stage and the other one can come back. That whole Fox Lake sub is basically single track. So in the dispatcher world, this is a screenshot of the CAD screen. Is one train can come here, and this would be called the passing siding, and then the dispatcher can send the train this way. So what we're doing is giving the dispatcher options so that we're not delaying trains and holding them back. So how does this look from an engineering standpoint for any of you structural or civil engineers? Is we have an existing structure and we're going to build a parallel structure. So we're not going to affect train traffic at all. We're going to build a parallel structure to it over the creek using these built-up girders, and and then eventually cut over the passing siding. So just some details for any of you that are interested in this about what it is. It's a ballasted deck bridge, but what I want to point out is the number one rule of engineering, and I'm pretty sure U of I teaches this, is drainage, drainage, drainage. You have to have drainage on your bridge, but thinking of the end users, who else is using this bridge? Signalmen use it, electricians if we have to power something. So we add conduits so that you can run cables across the bridge, because if you don't do this, how are you going to run a signal cable across this bridge? The only other option is dig up the bridge deck and put it in there, which you don't want to be, because that signal or that cable will get damaged or severed. So forward thinking, you think of the end user and you add ducts so that in the future they can pull a cable whenever they need it. So for all the the structural, we always are thinking, how is this designed, the bolted connection and all that. This is like the next evolution, is think of the end user that might need that bridge. So this bridge is over a creek right here. And so we elected to use micro piles for the accessibility into this area. So it's a 35-foot micro pile that we're doing so that you can, that small rig can access the job site better than any other equipment. And then, those micro piles will be poured with a clear cap, and then the superstructure will be set. So this is just an example of one of our projects that we're using. It doesn't seem like much. You're going to build a parallel structure, but that right there on let's say a normal train ride from there is, an hour, let's say, or less. Well, now we just cut 8 minutes off that ride. So, like I said, just building one bridge, this capital investment is going to save all that time on the train ride. So kind of changing gears, that was a bridge project. We're going to talk about a signal project now that's happening right there at 59th Street on the Metra Electric District. So for those of you that don't know what's being built right next door, you might have seen this on the news, is the Obama Presidential Library is being built right by our station at 59th and 60th. So Metra is upgrading our station there to be fully ADA compliant with elevators and everything else. So it's not just a station upgrade, and that's what I'll get into is, so we're gonna, here's our station at 59th and 60th, and the Obama Center is gonna be here. What I'll show in the next slide is we're going to build this new station, but we have an antiquated signal system that's running through this territory of track. And so what I mean with an antiquated system is it currently can only run trains in one direction. So if you want to work on a platform on another track, you have to do what's called a track permit. So you literally will talk to the locomotive engineer, give them a physical, the dispatcher and locomotive engineer will have a job briefing and give them authority to run against the current of traffic. So this would be equivalent on the highways. You're running on the right side today, and all of a sudden they put you on the left side. You know, the signals you see green means go. There's no signals on the other side for you. It's the same exact scenario we have here. There's no signal for that locomotive engineer on the other tracks. So in order to build this station, we need to add those signals so that we can run trains on other tracks and build the new station. This is just a snapshot of what a track permit is for those of you that don't know. A dispatcher and an engineer would have to, like I said, have a job briefing and physically write this down, which would take about 15 to 20 minutes per train. And there's 100 trains a day going through here. So the station could never be built with the current infrastructure. So in order to build the station, we have to upgrade the signal system. So we're upgrading the signal system right now, and the station project is going to follow right behind it. So what that looks like, kind of, this is a snapshot of a signal diagram. Red is out, yellow is in. So if you can see these red, these are one, single-headed signals. So they can only control a train in one direction. The yellow are bidirectional, so they can control the movements in two directions. So we are currently working on this project so that we can upgrade the signal system, and like I said, then station work will follow behind. And so what that kind of looks like, if any of you have never been on our electric line, is it's all overhead catenary system, electrified territory. And so all these are what the signals look like on top of our structures. And here's some more like high mass signals. So we'll have to work in this environment, replacing all this infrastructure. Along with those signal upgrades is, right-of-way work for powering all these signals. And then to the right is what's called a substation, where we get power from ComEd and convert it from high voltage to 1500 volts DC for our trains to run on. So we also have to upgrade the substations to accommodate all this signal work. This is just a video of what we call a tower car. Tower car is how we maintain the overhead catenary system. So I'm just trying to show you the environment in which you have to work to change out all these signals and everything else. That platform can articulate up and down also. So that's the end of what I was talking about with signal upgrades. Now I'm going to switch gear. This is about crossing gates and road crossings and what we're doing to enhance them. So I think most people in the room have probably seen a scenario like this where a crossing gate gets hit and, police are at the scene, or, railroad forces are working. Currently, when this happens, the way you get notified is by police or John Q. Public are telling you what happened. What we're working on right now is what we call smart crossings, and other railroads are working on this too, is we're waiting on that notification basically that a gate got damaged. What a smart crossing is putting sensors on crossings so that when a crossing gate got hit, it'll notify the dispatcher, and then we can dispatch out maintainers to repair the gate. Another issue that will happen is, let's say you lose commercial power. You lose power at a road crossing. We have battery backups, but we don't know we lost power right away. And then all of a sudden you could find out hours later. Versus when you have a smart crossing, it'll have a sensor that says you lost power. We can right away call ComEd and get power, restoration. So we're working on these, and this is another piece to increase on-time performance, because when a road crossing gate gets hit, trains have to stop and proceed through that road crossing, going slower and delaying more and more trains. So the faster we can respond to these incidents and know about them, the increase in on-time performance. These are just a couple of dashboards of what this looks like as a like a smart crossing. You have all these inputs, like I said, commercial power, the gate, all those things, and you know, they'll show, you know, green being good or red being bad. So you have a dashboard, and then you'll have like asset health. It'll show you where you're at. So we'll have our signal forces monitoring this, and then an alert will go out when any issue happens. So this is like, you know, the back office monitoring this, and then you'll have a dashboard for each individual crossing that if you needed to check on it. And then, you know, there's an asset registry of all these things. So we're in the works of doing this on one of our electric lines that runs kind of like an interurban in between road traffic. So we have a lot of incidents there. So we are upgrading those crossings so that we can increase our on-time performance over there. Switching gears into another leveraging technology. So what you see here right now is a drone launching, and it'll get up in the air in a minute, but we're using drones and other technologies to help us do capital planning. So the bridge that this is about to go over is, you know, over 100-year-old truss bridge that we're planning on restoring. So we need to do steel repairs and then painting of it. Well, we sent up a drone, and as you can see, drone will tell you if you have a cracked gusset plate or a missing bolt. It's a lot safer than sending someone up there to climb and measure. So we're using drone technology for bridge inspection. Railroads also use drones for derailments. If there's any like hazard issue, you can put a drone so you're not putting people in a hazard way. So Metra, along with all the other railroads, are leveraging this technology to make a safer work environment. What you can do with that drone is you can do 3D modeling with this. And like I said, for this bridge right now, we're planning on steel repairs and sandblasting and painting, because this bridge is so massive, you're not going to replace this. We want to rehabilitate this asset. So we're going to use this modeling to then help put together a bid package for how would a contractor confine this area to, let's say, sandblast it and paint it while also running trains. So like I said, this is a way we're using technology to then use our capital funding. I put on here some upcoming opportunities. This is more for the contracting and consulting world, but that first bridge I showed you, that will be going out to bid here in the next month or two. We have some other bridge work that's going out to bid. We also have ongoing what's called bridge repair work that's always going, that'll go out to bid. We have a lot of station work that's always going out to bid, and I have a link on the slide that I can share with you, Riley, but there's always contracting opportunities at Metra. And then on the work that we kind of perform in-house but use contractors, I mean, we have hundreds of miles of right-of-way, so we hire tree trimming contractors every year to help us because we can't cut a 50-foot tall tree. So we'll help with that. We have paving, all the road crossings we do. We have to get pavers to then, pave the approaches. Weed spraying is something you probably never think of, but we contract that out too. You have to spray your entire right-of-way. Otherwise, you have weeds growing through your track. So there's lots of opportunities out there. Also, these are links, and I'll send you these, Riley, but we're always hiring too. We're looking to put on more interns, electrical engineers, civil engineers, signal engineers. We're currently hiring engineers. We have posted civil engineer now. We're looking to hire bridge supervisors. And then we, as I mentioned earlier, we're offering veterans preference too during that hiring. And so these are all hyperlinks and I'll get them to the group. So this is, the basics I had, Riley, and I'm open for any questions you guys want to go over or.
Ron, a couple of quick questions for me to get it kicked off. When you showed some of that, interesting to see is most of that fall in your right way or coordinating with the local municipalities. I couldn't see exactly how far from track center.
Yeah, so those are all our retaining walls. And so what happened when the city of Chicago made all the railroads elevate is they built these retaining walls with old limestone. And, over the past, 125 years, trees and everything else have now degraded some of these walls. So those are all our walls that, everyone, you see the viaduct when you drive through the city, you see the bridge, but you don't realize every block, there's a block of retaining wall in between. And so all that infrastructure is ours too.
So let me ask one more follow-up to that one. There's a good question from the online audience. You may need to repeat this for they're not hearing me. Did you see any other retaining wall failures in your geometry data? Or were these all visually identified, from the right of way?
Geometry from track? No, so we didn't have any track settlement. There was no issues at track level. Most of these retaining walls are far enough away from track level, so we didn't have any settlement in the track. But these are from annual visual inspections.
You're not the only commuter agency in the Chicagoland area. You've got CTA and so on. How do you coordinate with those folks so that everything tries to tie together, or is it impossible task?
So we coordinate with a lot of departments. I would say CTA, we have a whole department of community relations that we work with. So in City of Chicago, all the aldermen and then all the villages. So we have a whole department that we give them all our construction projects, and we try to give them a heads up that like that retaining wall, that we had to shut down the alley to do some of that work. So we're coordinating with them. And then we have, let's just say, certain areas where on the electric line, we have our trains and then CN runs parallel to us. So then we coordinate with CN when we have projects. So there's a ton of coordination with Metra since it's like a mixed use of freight railroads. So yeah, with CTA, we have to coordinate with other freight railroads and all the local municipalities.
Yeah, I guess my first question, I guess, is kind of going off of that. What is it like working with the South Shore line and like the Northern Indiana Commuter District, I guess, because they run on your tracks, I guess, up into Millennium, right?
Correct.
So I guess how is that infrastructure management done, and I guess that sharing?
So NICD has their own infrastructure until they get into Chicago, and they get on our tracks at a junction called Kensington, and then they run on our tracks under an agreement, purchase of service agreement. So we maintain our tracks, and then their crews run their trains on our tracks up to Millennium. We have a whole nother project I didn't talk about here that we call the fourth track up by Millennium Station. We're adding a fourth main for the increase in NICD traffic. So we're building from roughly Roosevelt north up to Millennium, a fourth main to accommodate all that additional traffic.
Get a couple of the online questions here. Can you expand on the process of undertaking capital projects to improve Metra's service on corridors that are owned by the other railroads?
Yeah, do they have a specific?
No, but I guess how do you identify challenges on UP West or something?
Yeah. So what I can say is, so we coordinate with the other freight partners and they put together their capital plans and we work with them. So, for example, the BNSF, we were just coordinating with, is they want to upgrade a couple of their key control points to high-speed turnouts to increase fluidity. So we'll work with them indirectly because we partially fund their capital programs through an agreement. So like the BN will agree to their capital program, which will increase the fluidity of Metra trains. And then we have a whole, let's say, UP North Line bridges that we're putting out to bid. That's a corridor improvement. We're replacing all those bridges in a corridor on the UP right away.
Okay. I'm going to jump around. There's a lot of questions on here.
Yeah.
Right, and it's in different topic areas. So with the bidirectional signaling project you referred to on the electric district, are there any other operational changes that are planned other than reroutes around the station project? There be any permanent changes to scheduling and operations after the station is built using the bidirectional signals?
So for the electric line, we have some larger global plans. We want to upgrade that section, obviously, for bidirectional flow of traffic. We also want to add, increase the speed on the electric line. So there's some other infrastructure plans that we have in the works to upgrade track speed and signal speed throughout that corridor, farther down the line. So, and we want to add a couple more crossovers, because if you look at the electric line infrastructure, there's large sections without a crossover. So we want to have more fluidity on that line.
Along, great answer. Several good questions there. Somebody indicates that they're testing on the electric district at much higher speeds. And to your point a minute ago, is there any estimate for when customers may see higher speed operations on the electric district?
So that's currently in the works. I will say we just ran a geometry car through the line to prove that track-wise it can have increased speeds. And now we have to, there's a larger project that has been talked about called MED 90. There's a lot of pieces involved in that. And so we have to test the infrastructure and say, okay, it's good for higher speeds. Now we need to test the rail cars and say they're good for higher speeds.
Okay.
And then also the PTC system, which is positive train control. There's braking algorithms and all that built in. We have to prove that the braking algorithms are for the higher speeds also. So it's kind of a larger project that's in the works, but there's many pieces to it.
Okay. There's a disproportionate number of questions about the electric district, it seems like. So I'm going to give you one more, because that's something actually a lot of us are not as familiar with. Many of us that are on the track side. Question is, can you elaborate more on what the typical maintenance looks like on the OCS systems and how capital intensive it is? Just speak a little bit to that.
Yeah, so the electric line is basically what I call it is two railroads. You have the railroad on the tracks and the railroad above. So to work on the electric line, it's very intensive. So yeah, we inspect the overhead catenary and repair that. We have a whole crew dedicated that to repair the catenary structures. That's a B&B crew that they're working on that all year long. So we have just a crew dedicated to all that steel infrastructure. So we also, like, a challenge for the electric line is the overhead catenary above, you know, goes through the train. That's for the motors. The return current goes through the rail. So there's hundreds of what we call impedance bonds that have to go at track level for the return current to go to work with the signal system. So it is very capital intensive on the electric line.
Okay, nice. So I guess my question is, I guess relating to the transit bill that Illinois passed late last year, I guess first off, do you think that will have an impact on how Metra conducts like its capital improvement, or like what its priorities will be for capital improvement? And I guess if you do think there will be a change, I guess what will that change look like?
So there's specific language in the bill, you know, and it's kind of a work in progress. I can't speak on exactly, because there's going to be a new board that oversees Metra. But the bill, it wants us to coordinate with other agencies, like you guys mentioned, CTA and PACE. The bill also talks about studies to increase service. So like the Rock Island is spelled out to increase service there. And then there's also studies to expand service, let's say down to Kankakee and other areas. So those will be forthcoming, but you know, when that comes, we'll work on it.
I asked this a couple of years ago when somebody from Metra was here, but curious about one particular rather antiquated infrastructure piece, and that's the Western Avenue Tower A2
I knew you were
project. Yeah, my beloved tower. But as much as I don't want to see it go, I'm curious just what the timetable is how much engineering, how far is it down the pike, budget wise, planning wise, and that sort of thing.
So A2 is our last tower that we have manned. We had another one at 16th Street. We remoted that tower last year. So A2 is our last tower. There is a larger unfunded project that talks about, because our lines and the UP's lines cross at A2, that if you could, there's also property in between Metra and UP. If you could procure that property, you could untangle all these lines and then eliminate A2. Those are all on the shelf, but they are not funded. So A2 is not going anywhere. We have to globally figure out, like you said, you either buy the property and untangle lines, or you would have to build a flyover, like the one I showed earlier at Forest Hill. So none of those options right now are fully funded, and that's probably going to be I would assume, a NIDA board initiative, because there's about 200 trains that go through that A2 a day, that if you could reduce the conflict, you would, you know, increase on-time performance. So, but A2 we maintain engineering wise. We have maintainers there, track there. It's a busy place.
Hey, two questions. How are you doing on your 95% on-time performance? And then are you getting back the pre-pandemic ridership?
Yeah, I heard them. So the on-time performance, how are we doing? We last month were 94 point, I believe, 8. So we were right there. We missed it a little bit. So our goal is obviously 95. Sometimes when you have major events, you can get 10, 20 trains in a row. So it's all sometimes we try our best on the engineering side, on transportation and mechanical, to rally to reduce these events. But every once in a while you get a major one, and so like we just barely missed it last month. But as far as pre-pandemic ridership, we're at roughly, Kevin, at 60 in the 60-some% of pre-pandemic. We have increased over the past 2-3 years. Year over year, we're increasing, but we're not at 100% of 2019.
It's not now?
Yeah.
Okay. I was wondering, so I feel you, or like you had a very clear definition of what like Metra's priorities are. I was wondering, as like chief engineer, like what your day-to-day like big fish are.
Yeah, good question. So as a chief engineer, what I look at is basically our 4 core, like let's say buckets that I look at is safety is number 1, service, our financials, and our people. And I can, safety is we got to go home in the same condition that we came in. So we're 750 people. 750 of us need to go home in the same condition. And that's a whole gamut of things, from PPE to following rules to training. Service is like, here what we did. We're providing a service. So we have tie gangs, rail gangs, bridge gangs, all these projects. So that's like, another one. Then what follows behind that is you have to be within budget, right? So we have 2 budgets. We have an operating budget and a capital budget. So we have to work within our means and use our capital strategically to benefit the company. And then the last like core tenet that I have is like our people. You have to keep developing your people. You got to keep investing. So that's through like stuff like this, professional development. It's through training courses. It's like cross-pollinating. So like things that we've been working on are, let's say you work in the track department. Let's have you go to a bridge inspection class. So now if a bridge gets hit, you know, you can relay the information to, let's say, the bridge supervisor, and we can have trains move. So we're trying to also cross train all our department.
Good answer. So a couple more questions. One that relates to just prioritization of investments, another one that's in that vein. Does Metra's engineering team interface with some type of a network simulation group to help evaluate different project impacts, or how do you figure out capacity upgrade impacts?
With the other lines like CTA or?
Like even that junction, how to prioritize it, round out at the junction there versus another capital project, how it affects fluidity differently, your use of money.
So what we have every year is what we call a call for projects. We have a planning group that everyone, let's say, submits the projects that they deem necessary. And then we grade all these projects. So, you know, I would say the core functions, like you're going to do ties every year, you're going to do road crossings every year. Those don't get graded as much because those are necessary to keep the railroad running. But all the additional projects are put together and we grade them on certain criteria. Does that create service? Does it improve safety? And we have a whole list of criteria. We grade all these projects, we put them all together, and then so we prioritize them. And then there's also financial restraints. So like last year we graded them all, and I don't have the exact numbers, but let's just say we had, you know, 500 million in projects. We only funded 300 million. So then after we graded them, then we had to then go within our budget. So, but there's a whole process. We do this every year. We're actually going to start it soon for 27. We're submitting these projects, and then we coordinate this with all the departments.
I'll get maybe one or two more from the online audience. There are a couple of questions in the vein of PTC, and looking back now that PTC has been functional for several years, kind of what's the experience been thus far in terms of reliability, and can you comment on Metra's PTC experience?
Yeah, so Metra's PTC, along with all the other railroads, they like to say something called 5 nines, where it's 99.999%, you know, efficient. So obviously, it's a great system. It's an overlay system to prevent any issue on the main line. From an engineering standpoint, you know, it's additional infrastructure for us, additional assets to maintain. I think from a transportation standpoint, it was a learning curve with locomotive engineers having a system that could enforce the brakes on them. So, but I think as far as we're going on the engineering side, we're up and running. There's talks of, you know, improving it even more. Like what we're working on is using that system to leverage, like I showed earlier, a track permit, or there's something called track and time, is we can use that system now to request digital authorities on the main line. We don't currently have that. We're going to use our dispatching system to then now have digital authorities. So we're kind of working into, I would call it 2.0 now.
Great. I think we covered many of the online questions. How about one more from the room?
You mentioned, I thought it was an interesting example of the smart grade crossings and alerting. From kind of a holistic engineering standpoint, what do you think are locations where you think data would easily make your decisions, like day-to-day decisions, a lot easier on prioritizing engineering things? So be that track inspection, geometry data, or other types of IoT devices or data that you can gather from the infrastructure that will help you or your engineering team make decisions.
Yeah, exactly. So that's what we are using for this, what we call for projects every year, is we track that in on-time performance. We track these 671 trains and we code each one of them up, like what caused it. Was it a signal delay? Was it a bridge strike? What is that? So we're using those train delays to then say, here's where we're having a problem. But to your point, like the smart crossing is going to be the next evolution with it is now we're going to say, we've had 50 train delays at this road crossing, and this road crossing has got hit X number of times, and now we'll have the data from the smart crossing to, let's say we can work with the, you know, the local municipality. Maybe we close a crossing and divert traffic to this. Then we'll have the data that we can work with IDOT and other people to improve. A lot of the issues we have are roadway improvements. Like the way the road is set up, it's diverting traffic. Like when we have our railroad lines on an angle going through, you know, two crossings, we have issues where sometimes people they'll turn down the track instead of down the road. You know, then you can get, let's say, with the state and add physical barricades, things like that to divert the road traffic. So to your point exactly, we're going to leverage this data.
Great. I think we'll wrap it up. Thought that was tremendous. Thanks for fielding so many questions and thanks for coming down here. We have a small gift for both you and for Kevin back there in the back.
Oh, thank you.
A Railtech mug.
Thank you. Oh,
Is
nice.
on there of some of our alums, but thank you so much for coming down
Appreciate it.
down here.